Good morning, guys. So today is day one of our 3-day review for your district benchmark that will be assigned to you on Thursday. I emailed a letter home to you and your parents Sunday night explaining what the district benchmark is, why it's important. And there's a lot of information in that email and the attachment that I put in there. So make sure you go through and read that. It does have the test code, but I would suggest that you not take the test until you've gone through the 3-day review. We're going to review physics today, and then we're going to split chemistry in half and do some of chemistry tomorrow and some more chemistry on Wednesday before we take the test on Thursday. So let's go ahead and get to the physics review. So, and this review is geared towards what you're going to see on the test. So it is not encompassing of everything that we talked about, but it does include some skills that you're going to need for the benchmark. So the first thing we want to talk about is net force. Remember, net force is determined using the free body diagrams, and you'll have to look at the direction of the force and the magnitude of the force, remembering that if the forces are in the same direction, we're going to add them together, and then if the forces are in different directions, we're going to subtract them. And we always subtract the smaller force from the larger force, and the object will always accelerate in the direction of the larger force. So, for example, up here, we have 1,200 newtons up, 800 newtons down. So that's opposite. So we're going to subtract 1,200 minus 800 is 400 newtons, and the largest force is pulling up. Down here, or on this one here, we have 800 newtons gravitational force, 600 newtons of air uplift force. So again, we subtract the smaller number from the bigger number, and that's 200 newtons, and the larger force is pulling down, so it would be 200 newtons down. And then over here on the right, this is one where you have three different forces acting on the object. So you always want to work in opposites first. So if we just look in the up and down direction, notice that it's 50 and 50. So this would be unbalanced, or balanced, sorry, because we would subtract 50 minus 50 to get 0. So in the up and down direction, those forces would cancel out, and so we would have a balanced force in the up and down directions, but there is this frictional force pulling to the left of 20 newtons. So the overall net force acting on this object would be 20 newtons to the left. There's some more examples over here on the left as far as opposites and same direction, just to kind of refresh your memory about whether we're adding or subtracting in those directions. Okay. So you're going to also have to calculate some acceleration given some forces and masses. The issue is, however, I think on the test, it's not going to give you a table like you see here on the left. It's just going to give you a graph and ask you to determine what the acceleration was. So if the line is straight, the easiest way to determine acceleration is pick any point on the line. So we're going to choose this one right here. And then this one has a force of 6 and has a mass of 15. Okay, so in order to determine acceleration, it's force divided by mass. So if the force is 6 and the mass is 15, then if you do that division, you come up with an answer of 0.4. Okay, and because this line is straight, what I want you to notice is no matter what point I choose, it's all going to be the same. So 2 divided by 5 is going to be the same as 4 divided by 10. This is going to be the same as 6 divided by 15. It's going to be the same as 8 divided by 20. And this shows you here how all of those answers are the same. So notice that because the line is straight, acceleration is constant. Okay, so this vehicle or object is constantly accelerating given this information. Okay, so again, on the test, you may be asked to calculate the acceleration, but not be given the data table. You may just be given the graph. So again, pick any point on the graph, figure out what the force is for that point, figure out what the mass is for that point, and do your calculations. When forces are balanced, that means there is no acceleration. So one of the things I want to make sure you understand is no acceleration does not mean that it's stopped. No acceleration means that there's no change in what the vehicle or object is doing. So in a distance time graph, which this is not, in a distance time graph, a horizontal line here would show no motion. But in a velocity time graph, this shows that the car was moving at a constant velocity of 3 meters per second for 2 seconds here. So the story of this graph would be that this car was accelerating, speeding up, then it stayed at the same speed. It got to 3 meters per second and then stayed at 3 meters per second for 2 seconds. And then it accelerated a lot quicker here. Remember, the slope of the line talks about its different acceleration. And then here, when it's going down, that means it's negative acceleration. It says deceleration here, but the official term that we would use is negative acceleration, back down to the stopping or 0 meters per second speed. So again, the story here is this car was accelerating, speeding up, got to 3 meters per second, stayed at 3 meters per second. Then it accelerated from 3 meters per second to 6 meters per second, and that took them 1 second there. And then it went from 6 meters per second to 0 meters per second over the last 3 seconds. Okay, so again, don't get confused with this. Again, you have to remember difference on the x and the y axis. If this were distance time, this would show no motion. But because it's velocity time, this actually shows that the car is moving at a constant speed or velocity. You'll again have to know the difference between, or actually know what velocity means. Remember that velocity is both speed and a direction. A car traveling at 25 miles per hour is its speed, but a car traveling at 25 miles per hour to the north is its velocity. Okay, so if a car goes 25 miles per hour to the north and then switches to the south, then it's velocity change, therefore that's acceleration. If the car was doing 25 miles per hour to the north and sped up to 35 miles per hour to the north, that is also acceleration because his velocity changed. So acceleration, remember, can be a change in either the speed or the direction of an object. Another question that you'll be asked is about calculating force, or knowing the formula force equals mass times acceleration. So the problem may give you mass and acceleration and ask you to find force. It may give you force and acceleration and ask you to find mass, or it may ask you or give you force and mass and ask you to determine the acceleration. And so there are the three formulas for you again. And then I think the last question on the test is going to ask you about Newton's third law. For every action, there's an equal and opposite reaction. So basically what that means is if object A hits object B with 100 newtons of force, then object B is going to hit object A with the same amount of force. Now, if you look at this picture here between the bird and the truck, if the bird and the truck, or if the bird hits the truck's windshield, right, whatever force the bird applied to the truck is going to be the same exact force that the truck applies to the bird. Now, the difference, of course, is going to be very different, or the difference is going to be in the result, right? So the bird may crack the windshield, may break the windshield, but it's not going to stop the truck. And then the bird, when it hits the truck, of course, the bird is not going to survive that interaction. Even though the result is different, okay, it doesn't mean that the force was more. So it does not mean that the truck hit the bird with more force, okay? It just means that the result may be different, okay? So remember that regardless of two things hitting each other, regardless of their mass or their size, the force that is applied to both is always, always, always going to be the same. Okay? So again, we hope that you're in the Zoom meeting, but if not, please make sure that you've watched this video, and remember to ask any questions that you may have. And again, the benchmark test will be assigned to you as your assignment on Thursday, and we'll put the code back up on Thursday in case you missed it in the letter that I emailed to you on Sunday. All right, guys, good luck.